Hey guys, my name is John, and we're back at it this week with week 6 of Chem 2 Interactives. This week, instead of being hands on with the interactive and displaying kind of what we're doing, I'm just going to kind of talk about it, as this week's interactive is about nuclear bombs and the composition and the chemistry behind nuclear bombs. So, we're not going to be making one or a model of one. Instead, I'm just going to explain kind of the details behind of what I learned about it and like how the reaction occurs inside of it, and then the components necessary to achieve the chain reaction required for nuclear fusion. So, a little background: nuclear bombs are composed of nuclear energy containing atomic nuclei. Uh, they're released during nuclear reactions and radioactive decay. Okay, so there's two types of different nuclear bombs that are most often thought of as the same, but they are different. Those two types are an atomic bomb and a hydrogen bomb. So these are both types of nuclear bombs, but both are different and both have different chemicals and components that make it up and how the reaction occurs. So first, let's talk about the atomic bomb. The atomic bomb is a chain reaction of the fission of heavy nuclei, uranium-235, and also it could be uranium-238 and 234. Those numbers stand for the isotopes, which, to get into more detail, we're not going to, but those isotopes all stand for a different type of uranium and how that certain element reacts inside. Okay, so most often with atomic bombs, we see uranium-235 as the one that reaches the most maximum energy production. Therefore, that is the most commonly used type of uranium is the 235 for these atomic bombs. Plutonium-239 can also be used. This is a rare element being used just because it's not easily found in nature. So therefore, if we were to use plutonium-239, it would have to be made up artificially. Okay? So going off of that, nuclear explosion occurs. This occurs due to the critical mass inside the bomb for atomic bombs. Normally, one critical mass, not normally, almost always, one critical mass is not sufficient enough to aid in the explosion of the bomb. Therefore, 4 to 5 critical masses of matter are needed for a truly destructive bomb, with the main one being the implosive critical mass. Okay, so that's just the background on the atomic bomb. The hydrogen bomb, not going to talk about it as much, but just a little background with it. Energy is released during the thermonuclear fusion, a very fast explosive reaction thanks to deuterium and tritium. These elements are used, and then the main element that we see is the lithium hydride. This is also, to go with this, needs to have an integrated nuclear device to explode or create the energy needed, because that lithium hydride cannot explode on its own. So that kind of is what sets apart the hydrogen bomb versus the atomic bomb, just the inner chemical components of it, the differences between the elements, and what we see as far as how the energy is released. Because that energy is released, an atomic bomb with the chain reaction of the fission of heavy nuclei, and in the hydrogen bomb, it's due to the thermonuclear fusion. And then the different elements that we talked about, uranium-235 for the atomic bomb, and then the lithium hydride for the hydrogen bomb. With these two types of bonds, radiation is a primary factor caused by the explosion of these nuclear weapons, as we saw in two of the most famous bombings, Hiroshima and Nagasaki. So radiation, the after effects, there's 3 types of ionizing radiation: alpha, beta, and gamma. Alpha does not cause much harm. If you have clothes on, you're well protected. It doesn't cause much harm. Beta is a little bit more harmful to the body. If you're within a certain radius of the explosion, it can cause some significant damage like radiation burns and cataracts. Gamma radiation is kind of what we need to be careful of, and what people closest to these types of bombings need to be careful of, because gamma radiation is a lethal type of radiation. This can lead to death ultimately. Radiation sickness and cancer, 2 things that we see most of the time, and genetic mutation. So that's just a little bit of the after effects of what can happen from an atomic and hydrogen bomb. So let's get to what is occurring inside this reaction. So inside the reaction of the bomb, nuclear fission produces the atomic bomb, the weapon of mass destruction that uses power released by the splitting of the atomic nuclei, as I kind of stated when we talked about the atomic bomb. When a single free neutron strikes the nucleus of an atom inside of a radioactive material like uranium or plutonium, like we talked about, it knocks 2 or 3 more neutrons free. And this aids in the ignition of that bomb. Okay? So, what components are necessary to achieve the reaction required for nuclear fusion? So, fusion requires temperatures at about 100 million Kelvin. This is about 6 times hotter than the sun's core. At these temperatures, hydrogen is a plasma and not a gas, which is important to note. Plasma is a high energy state of matter in which all the electrons are stripped from the atoms and they move freely about. So, the two main components to achieve the chain reaction required for nuclear fusion are a high temperature and a low pressure. Without these two factors, the end result of nuclear fusion is unachievable, and therefore the creation of our atomic bomb and the success of it to ignite is unattainable. So that is kind of the background of a nuclear bomb. So I hope you enjoyed and have a good one.